So we've seen that U substitution is really just undoing the chain rule. And in looking at the chain rule, we sort of saw that there were three clues that suggested we might want to do a U substitution. The first was that if I have as my integrand the result of chain rule, I'm going to have a product of two functions because I've got f prime times g prime. The second is that one of those factors is going to be a composition. That'll be the f prime evaluated at g of x. And then the third clue was that the other factor is the derivative of the inside part. Okay. So up until now, all of the problems that we've done, we've had a perfect match. The integrand was exactly what we would get if we applied chain rule to a function composition. Life is not always so kind. So I want to start taking a look at some situations where we don't have all of these clues, or where we don't necessarily have a perfect match, but we can still modify things and do a U substitution. So I've got this definite integral up here. We're integrating from e squared to e cubed, natural log of x over x with respect to x. Now, I just want to point out that anytime you've got a division problem, you can rewrite it if you want to as a multiplication problem. That's 1 over x times the natural log of x dx. A fraction is just the reciprocal of the bottom times the top, or the top times the reciprocal of the bottom. Order doesn't really matter. So I do have now a product. Now, neither of these factors is a function composition, but there is a very strong connection between the two factors because this one is the derivative of that one. Okay. So if I did a U sub, I'd just get U equals the natural log of x. U prime is 1 over x. Du would be 1 over x dx. So I can now rewrite this. We're going to get the integral from the u value at e squared, which would be the natural log of e squared, which is just 2, because the natural log and the exponential functions undo each other. Similarly, the natural log of e cubed is just 3. Now the 1 over x and the dx, that becomes my du. Natural log of x just becomes u. Okay. So because I didn't have a function composition, I'm not doing anything to u. My integrand is just u. That's perfectly fine. So if I end up with a product where one factor is the derivative of the other, a u substitution will work. So now I can say this is going to be u squared over 2, evaluated between 3 and 2. And so that's going to be 9 halves minus 4 halves. I could keep that as 9 halves minus 2, or I think I'm just going to combine that into one fraction and say that's going to give me 5 halves.